And finally, we have problem 40 in chapter 3. It's a dot product and a cross product. We don't really, no, we really don't need dot product for this class, but this was a pretty good problem just in terms of the cross product and what you'll need for your WebAssign problem. And so I'll do this one anyway. So basically you have three vectors, A, B, and C, and we want to do uh, 3C dot 2A cross B. And you can read this in your book, but I'll just write it out just for good measure. A is 2I plus 3J minus 4K. B is negative 3I plus 4J plus 2K. C is 7I minus 8J. Don't forget I is the x direction, J is the y direction, and K is the z direction. So we can do PEMDAS here and do the inside the parentheses first. So, let's do 2A. What would 2A be? That's pretty simple. It's really just 2 times A. So 2A is going to equal, well, let's not be too confusing. 2A is going to equal 4I. You just multiply 2 by each of the coefficients here, plus 6J minus 8K. That wasn't too bad. And now we get to cross 2A and B. So 2A cross B is going to equal, really just, it's a distributive thing, you really just multiply them. 4I plus 6J minus 8K times negative 3I plus 4J plus 2K. And let's distribute. So you go 4I term times all these, 6J term times all these, and the negative 8K term times all these. So let's just do it out. Are you ready? 4 times negative 3 is negative 12I plus 16IJ. I just did this times this. 4I times 2 is plus 8IK. Now I'm going to do the 6J through all these, and I'm just going to write them out now. Hopefully you can follow along. It's just the distribution property. So minus 18JI, and the order matters. Don't lose the order. Don't write IJ. Plus 24 plus 24JJ plus 12JK plus plus 24, what is that, plus, oh yeah, minus times minus, plus 24 KI minus 32 KJ minus 16 KK. Okay. Now, as we discussed before in the notes, with cross product, we use sign. Well, let's go back here. Yep. Cross product is the sign, of the angle between the two vectors. And so, whoops. First off, this is concept 6, just to let you know. That's what we've been doing so far, is listing that first. So the sine of 0 is 0. So since I and I are in the same direction, in the x direction, and the angle between I and I is 0, then the II term cancels, the JJ term and the KK term cancel because those are parallel. But I and J are perpendicular to each other. It's the coordinate axes. And so here you have I, here you have J, and here you have K. You can see I and J are perpendicular to each other. In fact, all of these are perpendicular. If they're not parallel, meaning II, JJ, and KK, then they're perpendicular. And so we have to figure out, using the right-hand rule, what I cross J turns into. And again, this is difficult to show on here without my hand, so ask me in class and I can show you that. But what you do, again, right-hand rule, maybe I can just copy this picture over. Control C, Control V, get you over here. So you take your pointer finger, you put it in the direction of the first one. For 16ij, the first one is I, so you put your pointer finger pointing that way. So that should be towards your right. And then you take your middle finger and you point it towards the second one, which is J, and that should be up. And if you do that, you're going to have to twist your hand. You'll notice your palm is facing up and your thumb is pointing towards you. And towards you is represented by positive K. So 16ij turns into 16, 16k, and it's positive. And you can do that. I'll do one more for you. You put your pointer finger in the I direction, that's pointing towards your right, this way. It's horrible. Towards your right. And you take your middle finger and you point it towards you, and that's going to kind of hurt your wrist a little bit. And basically that means your palm is kind of facing towards you. Your thumb should be pointing down towards the ground, which is this way, in the negative j. So that's plus 8 times negative j. I also could have written just minus 8j. But I'll just keep the signs for now. And then I'm just going to go through these, and you can verify them for yourself if you don't trust me. 18 negative k plus 12 I plus 24 j minus 32 negative I. And now we can combine I terms, j terms, and k terms because they're in the same direction, so you can add them just like 3 plus 7 is 10. So where's the i's? We got an I here, a 12i minus 32i, minus a negative, which is actually a positive. So 12i plus 32, that's 44i. For the j's, we got negative 8 and 24. So 24 minus 8, that's 16. And for the k's, we got 16 minus a negative, so 16 plus 18 is 34. 34k. And again, this equals 2a cross b. And really, I should stop here, but just for the sake of the problem, I'll do the dot product. You don't really have to know it, but it's pretty simple actually compared to the cross product. The cross product, you do a vector times a vector gives you a vector. So see, this is still a vector. When you do a scalar, you do a vector times a vector equals a scalar, or just a number. It has no vector, no direction. So let's do that. So 3c dot 2a cross b is going to equal c is 7i minus 8j, and 2a cross b is this now, simplified, 44i plus 16j plus 34k. And again, just distribute. 7 times 44, I don't know, 7 times 308. Oops. 308 I 7 times, what's going on here, plus 16. Why do those disappear? Do I not write them, or are they just disappearing later? I need a new tablet. 7 times 16 is, should have done this before. 7 times 16 is 112. That's plus 112 ij. Now, actually, let's just do a little shortcut because I'm already at 11.5 minutes. The dot product is the cosine of the angle between them. Remember, cross product is the sine. The dot product is cosine. Cosine of 0 is 1. And so when you have two parallel lines with the angle between them of 0, this equals just 1. So it's really 308. Whereas cosine of 90 is 0, and since I and j are 90 degrees, this term is 0. So any non-parallel vector is going to be 0, and I really can save some time by not even writing them. So 7 times 34, that's ik, that's going to be 0, because they're not parallel. Then we got negative 8j times 44i, that's 0, because j and I are perpendicular, so minus, I'll just call this a big X. And then minus 8j times 16, that works because j and j are parallel. So 8 times 16 is 128. That's minus 128. And I messed something up. I can fix that though. Minus 128 j, which is just 1, so that's minus 128. And then j times k is 0, so that's minus nothing. So we got 308 minus 128, but I messed something up. I forgot something here. Very easy to do. We actually need to multiply these by 3. And so this is not 7, this is actually 7 times 3, which is 21. So maybe I can be sneaky here and go 21. I don't think I can be so sneaky with 8. 3 times 8 is 24. Let's just erase that. And then actually while I'm at it, I'm going to have to erase this and this. So 21, it's 21 times 44, 924. So it's 924. And 24 times 16 is 384. I did that beforehand. So we got 924, and those are just numbers. These turn into 1, so those disappear. So 924 minus 384, and the answer is 540. That's the final answer. Yeah, so that's the dot product. Again, if you don't have the time to spend worrying about this, then disregard it. Up to here is fine. And that's 15 minutes. See you later.